going to talk about 6-7, graphing a tangent function and writing an equation of a tangent function. Okay? Graphing a tangent function and writing an equation of a tangent function. First of all, I want to remind you that tangent of an angle is equal to the sine divided by the cosine. Okay? That's important because when we look at tan of 0, we get sine of 0 divided by cosine of 0. Sorry. 0, not theta. And what's sine of 0 equal to? Sine of 0. 0. What's cosine of 0? 1. So what's 0 divided by 1? 0. So the tangent of 0 is also equal to 0.
That's a nice 0.
Yeah. Okay? That's not a problem, is it? But when I ask for tan of 90,
It would be undefined.
I get sine of 90 over cosine of 90. And sine of 90 is 1, and cosine of 90 is 0. And so in this case, it's undefined. Okay? So what happens when I go to graph that point? It's undefined. There's a hole of some kind, right? There's a point of discontinuity there. Okay? In this case, it's going to be an asymptote. All right? It's going to be an asymptote. And so, if I go to graph this, looks something like this. This would be pi over 2, pi, 3 pi over 2, 2 pi, and then we can continue on. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay? And we said at 90, which is pi over 2, what's happening? It's undefined. So there's an asymptote there. And so what if I put negative pi over 2 in? Negative pi over 2, I'm going to have another asymptote. Okay? And what do we say occurred at 0? What occurred at 0? No. Yeah, 0. So the value of the function is 0. That's not an asymptote, that's a number. So at 0, I have a dot there. Okay? Now we don't know exactly what's happening here, so if I wanted to, I might say, well, what is the tangent of 45, which would be pi over 4, right? And I might just plug that in my calculator, and what do I get? 1. 1, don't I? And what if I put negative 45? What do I get? Tangent of negative 45. Negative 1. So that should be right there. And so my graph looks like this. Okay. What is the period of that function? One what? 1 pi. Yeah, be careful saying 1 or 2. If you're thinking 2 marks, and each mark is pi over 2, then its period is pi.
So,
Okay?
tangents are like the sine and cosine values, because they're close to the horizontal.
Yeah, kind of. Yeah. And so, oops, here we go. We end up with an asymptote. Oh, I got lucky on that. Back to reality. Okay? We end up with an asymptote every pi units, and we're going to have a 0 here in the middle, a 1 halfway in between, a negative 1 halfway in between, and so my graph is going to look like this. Graph would look like that. Okay. Now that's what it would look like if I went from negative 2 pi to a positive 3 pi. Okay, that's what it would look like. If they told me to graph it from 0 to 2 pi, then I would just graph this right here, which you can't see on the video, so let me box this in. Just be that much right there. On page 396 and 397, there's properties of a tangent graph, properties of a cotangent graph, and then we actually 397 is cosecant and secant. We'll talk about them in just a minute. Take a minute to copy down the properties of a tangent and properties of a cotangent graph on page 396. Is that what I said? So before we get into cosecants and secant graphs, I want to first look at and remind you of what a sine graph looks like. So this is our sine graph, this red graph here, from negative 2 pi up to 2 pi. And so it looks like this. So it looks something like that. Try to put an arrow here. There we go. So it looks something like this, okay? Remember what cosecant is? It's the what? Reciprocal of sine. So right here the value of sine is 0. Right here the value of sine is, and here the value of sine is, and here, and here. So the value of sine is 0 in those 5 locations, right? Well, if I take the reciprocal of 0, what do I get? If I take 0 over some number and flip it over, what do I get? I get some number over 0, which is undefined. And so what that means is when I go to graph my, let me back up. If I go to graph my y equals cosecant x, try to make that cosecant. Try it one more time. Cosecant x. When I go to graph my cosecant graph, I have to understand that at these points, I'll move them. At these points right here, when the sign is 0, the cosecant is going to be undefined. Okay? The cosecant is going to be undefined at those points. And so there's going to be holes in the graph. Points of discontinuity. And so to graph a cosecant graph, this is what I do. I quickly graph or sketch or at least plot points for the sine graph. And in every place there's a high, I'm going to have a parabola that opens up. And every place there's a low, I'm going to have a parabola that opens down.
Got it. Don't worry, that is.
So the green graph is our cosecant graph. Okay? The green graph is our cosecant graph. Now, what do you think is going to happen? Oh, first of all, let's look back. What's the period of this cosecant graph?
2 pi.
2 pi, isn't it? If I just look at this little bit right here, which is 1 pi, sorry, let me box it in for those at home. If I just look at this little bit right here, okay, this parabola here is only covering half of the values. The other half are covered over here. Okay? And so it's 2 pi units from here to here. And then it starts over and it would be 2 pi again from here to here. And so my period is 2 pi, just like the sine graph. Okay? Just like the sine graph. Undo a bunch of that. All right. Now, if instead, we'll see if this works. If instead of a sine, I graph cosine, it would look like this, wouldn't it? Less. Okay. Now, where's my asymptotes going to occur in the cosine graph?
Would it be
What'd you say, pi over 2 and? Right. So you're saying right here and right here, where the cosine graph makes a 0, right? And so that would also be a negative pi over 2 and negative 3 pi over 2.
are those asymptotes for the secant?
Right, now we're talking about cosine, so the inverse of cosine is secant, and so the,
Why did they just match up and make cosine and cosine?
I don't know.
Good thought.
That's a good question. He said, for those at home, he said, why didn't they match up secant and cosecant instead of cosine and secant? There's a reason for that. It has to do with the inverse functions. Now, catching my writing up with my graph, what I have right now is the red graph indicates the cosine function, and so I have to move my parabolas over, don't I? To match up. something like this. I got enough dots there, don't I? Must have been excited to draw and I did everyone twice. Whoa, get back there.
He moved the whole line.
So now we have the graph of the secant, which is the inverse of the graph of the I didn't mean to say inverse. I meant to say reciprocal of the graph of the cosine. Okay? Again, if you brought up a secant graph to me and said, can you help me graph this? The first thing I would do is change the word secant to cosine. I would sketch the cosine graph real quickly, and then I would draw in my asymptotes and my parabolas to sketch the secant graph. Okay? And so, if I had a confusing looking secant graph that said something like this, y equals 3 secant 2 theta plus pi minus 1. First thing I would do is say, well, let's just look at the cosine of that. And though that'd be kind of confusing, and it'd take a little bit of work, that graph we practiced, haven't we? The midline has been moved up. This affects a phase change. This affects my period. This is my amplitude. So it's amplitude of 3 instead of 1, so it's stretched out a little bit more. Okay? I would plug all that in. I would draw my graph, and it might look something like this. Cosine. So it might, and it had a phase shift of something. So let's go over here. Say it looked like that. Then I would put in my midline that was -1. And I put in my asymptotes, which were wherever it was 0. Yeah, I didn't want to try to make it too accurate because I didn't put any thought into where it really goes. Okay? And then my secant graph then is actually going to be this. Okay? And so when I said I drew this green line, I said I sketched it, right? I sketched it very lightly, or I just put dots in there to find these points. Because I don't want anybody to interpret the green graph as part of my secant graph. It's not. It's the cosine graph that I use to help me find the secant graph. Okay? That's all it is. All right? Any questions on how I would graph that? All right. On page 397, page 397, there's properties to secant and cosecant graphs. Please copy them down. Just a reminder what the period is. You take notes on this. We've talked about this before. When you put a k in front of the variable, as I did after the fact here, they're kind of squeezed together. That changes our period from 2 pi over k for sine, cosine, secant, cosecant, and pi over k for tangent and cotangent. Okay? So the number in front of the angle is still going to affect the period. The k value still affects the period. Okay? All right, a couple examples. Actually, there's 3 examples I want to look at. Number 14 says find tangent of negative 8 pi. And they're saying look at the graph. So if we go back to look at the graph of tangent graph looks like this. Negative 8 pi. Well, this is negative pi. This is negative 2 pi. Negative 3 pi is over here. 4 pi, 5 pi. If I keep going, what's the value of the tangent of negative 8 pi going to be? 0, because everywhere on this, tangent of negative 8 pi, or tangent of any pi, any power of pi is going to be 0. So, to answer our question, it's equal to 0. Okay. If I look at 18, 18 says find the cotangent of negative 5 pi, cotangent of negative 5 pi,
So it would be,
we didn't actually draw them. What did we say was the difference between the cotangent and the tangent?
it would be the reciprocal.
Yeah, that'd be the reciprocal. So these would all be switched
So
around,
it would
right?
still be 0, right?
No, not quite. It is, but it's also translated over. It's shifted over because where I get this value in tangent, that value would be undefined
So, yeah,
in
it would be 5,
cotangent.
It would be negative 5.
Yeah, so
Since the negative 5 is 5.
my axis has, oops, doesn't do any good to move that. This line. Let me get that box out of here.
Since it's multiple times, it would be,
Well, I guess gotta move all these. They move over to here.
oh yeah.
They move over like that.
Why would it be 5 and not undefined?
What's that?
Why would it be 5 and not undefined? Like, wouldn't the answer just be undefined altogether?
To the most recent question,
Yeah. Yeah, number 18.
yeah, 18 is undefined.
Alright.
But we just oversimplified, I oversimplified what this graph was gonna look like. The majority of it is switching the line over like we did the curve. we flip this, oops. We flip this over, and so it went this way instead of this way, okay? But also, because we flip that over, it changes the asymptotes. And so instead of being at pi over 2, they're at pi, 2 pi, 3 pi, negative pi, negative 2 pi, negative 3 pi,
-5.
all the way out to negative 5 pi, and so on, okay? And so it is undefined, okay? So this is equal to undefined. Okay? And then the last one is number 22. Number 22 says find the values of pi for which each equation is true. Cosecant theta equals -1.
1.
Cosecant theta equals -1. They want us to find all the values of theta.
That's
22
23.
is secant.
Oh, did I look at it wrong?
No, we can do 23.
Yeah.
We take
Secant theta equals equals +1, doesn't it? It doesn't matter. It won't be hard for you after you look at this. Okay, so if we look at the secant graph, this is our secant graph. I changed my cosecant into secant, so we couldn't have looked at the graph for that one anyway. The secant graph, they said, is -1. Well, that occurs here, and here, and over here,
+1.
right? And over there somewhere.
I thought it was +1, not -1.
Oh, you're right. +1. I'm still on the other one. I'm getting there. So it's actually there, and there, and there. It's +1, not
Would it be
-1.
pi n?
Okay, so where does that occur? It occurred at 0, at 2 pi, at 4 pi, at, where's it going to occur again?
3 pi.
No,
6 pi.
at 6 pi.
Oh. 4
Pi n, right?
Yeah, at all the even pi's, right? So you could say pi n whenever n is even integer, or you could say at 2 pi n, or 2n times pi, okay? Where n is just any integer.
Would it be plus or negative?
No, n is an
Oh, yes.
integer.
Oh, yeah.
We say any integer. So that would cover the negatives. Okay? Any questions on that? All right. Today's assignment
13
is 13 to 27. Tomorrow's is 27 to 39. So altogether you have 13 to 39.
Wait, what was tomorrow?
29 to 39.